At Flixborough, 60 miles from the North Sea, beside a bend in the River Trent, there was once a place that made the thread of modern Britain. Not cloth, not steel, but the chemical precursor to nylon, the invisible ingredient woven into the carpets under your feet, the rope coiled on a fishing trawler, the fabric of a nation that believed it had conquered the industrial world. The plant at Flixborough was Britain's only producer of Caprolactam, the only one. If it ran, the country's nylon industry ran with it. By the spring of 1974, it was operating at 47,000 tonnes a year, short of the 70,000 it had been designed to reach, but running nonetheless, still working, still producing, still essential. On the first day of June that year, at 23 minutes to 5 in the afternoon, it stopped. Not slowly, not after a boardroom review or a government inquiry or a gradual loss of orders. It stopped in a single afternoon, in a cloud of vapour and fire that the atomic weapons establishment at Aldermaston would later measure through its seismic aftermath. 28 people lost their lives. The only plant of its kind in the United Kingdom was gone. But that is the end. The beginning is smaller and quieter. The land beside the Trent at Flixborough had served industry long before nylon entered anyone's vocabulary. The site had originally been arranged to extract value from the byproducts of nearby coke ovens, a utilitarian purpose for a utilitarian stretch of Lincolnshire flatland. In 1964, Fisons and Dutch State Mines, known as DSM, formed a joint venture they called Nypro. The purpose was precise: to manufacture nylon-6, a polymer that post-war British industry needed in volumes that importing could not reliably cover. By 1967, the plant had been reconfigured around Caprolactam production, the chemical building block that, once processed further, becomes the fibre running through 1,000 everyday objects. DSM held 55% of Nypro. The National Coal Board held the remaining 45%. The site spread across more than 60 acres. Around 560 people worked there. It was not glamorous. It was necessary. In 1969, Nypro announced it would treble capacity, pushing towards 75,000 tonnes a year. By 1972, DSM had brought its own cyclohexane-based process to Flixborough, a proprietary method that tied the plant more tightly to a specific chemical pathway. The investment was real. The ambition was real. Nypro functioned, by any measure, as a piece of critical national infrastructure. The kind of plant whose continued operation was assumed rather than celebrated, the way electricity from a power station is assumed. Nobody thought about it. It was simply there, still working, still trusted, still supplying. Then, at the turn of 1974, the commercial pressure began to show its edge. The plant was producing at roughly 2/3 of designed capacity and losing money at a rate that alarmed its directors. Nypro applied to the government's Prices Commission for authorization to raise the caprolactam price by 48%. The commission refused. Britain was deep in the energy crisis. The 3-day week had fractured output across the industrial north. Disruptions from the electricity shortages of late 1973 had already unsettled the plant's rhythm. And somewhere in the administrative decisions of early 1974, the post of works engineer fell vacant. The site mechanical engineer had departed for another position. The role was never filled. Not before March. Not before June. Not in time. In late March 1974, Reactor number 5 developed a vertical crack. Cyclohexane leaked. The plant shut down. The decision that followed was straightforward in commercial logic and catastrophic in engineering consequence. Remove the faulty reactor, connect number 4 and number 6 with a bypass pipe, and return to production. Under proper engineering discipline, that solution would have been drawn, calculated, scrutinized, and pressure tested before a single valve turned. What happened instead has become one of the defining case studies in the history of process safety. The bypass was designed by engineers with no specific training in high-pressure pipework. No formal drawings were produced. No structural calculations were completed. The layout of the pipe was sketched in chalk on the workshop floor. The finished assembly, which incorporated bellows and expansion joints not rated for the pressures and stresses the configuration would impose, sat on temporary scaffolding poles. It was never pressure tested. In process safety terms, this was a catastrophic management of change failure. The kind of modification introduced without the systematic review, documentation, and hazard assessment that MOC discipline exists to enforce. The Court of Inquiry later recorded, with the particular precision of understatement, that the post of works engineer had been vacant and that none of the senior personnel on site, who were chemical engineers, were capable of recognizing what amounted to a simple engineering problem. On the afternoon of 1 June 1974, the bypass failed. 30 tons of cyclohexane vapor escaped into the air above Flixborough. It reached an ignition source. The vapor cloud explosion released energy equivalent to 16 tons of TNT. The plant control room collapsed instantly, taking the lives of all 18 people inside it. 9 more workers perished on site. A delivery driver in his cab did not survive the blast. The fires burned for days. 49 fire appliances deployed at the height of the response, the largest firefighting operation in Britain since the 1940s. 1,000 buildings within a mile were damaged. In Scunthorpe, 3 miles distant, nearly 800 properties were affected. The detonation carried 35 miles from the river. Structural panels from the plant landed at North Ferriby, more than 10 miles away across the Humber. Had it been a weekday, the offices would have been full. Those who survived the immediate catastrophe moved through a landscape that Barbara Nimmo, a 21-year-old nurse who arrived to help, later described as a war zone. Financial losses reached an estimated $100 million. Every ton of Caprolactam that British industry required after that afternoon had to be sourced from abroad. The country's sole nylon-6 precursor was gone. The Court of Inquiry, reporting under HMSO in 1975, concluded that the disaster resulted from the introduction into a well-designed and constructed plant of a modification which destroyed its integrity. A competing reading, developed across decades of process safety analysis, locates the deeper cause not in a single pipe, but in the conditions surrounding it. The commercial pressure, the refused price increase, the vacancy that went unfilled. An organisation operating, as one analysis noted, without a clear understanding that process safety formed a discipline quite separate from personal safety at work. Trevor Kletz, the ICI safety advisor who would become the founding voice of inherently safer design, drew on Flixborough directly when he argued that accidents are caused by management systems, not just by individual failures. What had happened beside the Trent, he observed, was not a bolt from the blue, but the visible surface of something structural, layers of failed defences that James Reason's later work on organisational accidents would give a name. The Swiss cheese model, in which every slice of protection had its holes, and at Flixborough, on that particular afternoon, the holes aligned. According to this view, the chalk sketch on the floor was not an aberration. It was the symptom. The lesson did not stay local. 2 years after Flixborough, the Seveso disaster in Italy released a toxic cloud of dioxin across the Lombardy countryside. Together, those 2 events reshaped European industrial regulation. A decade after Bhopal in 1984, where a management of change breakdown at a Union Carbide pesticide plant killed thousands overnight, the world understood that Flixborough had not been an isolated warning. And when investigators stood in the wreckage of the Texas City refinery in 2005, the same structural patterns appeared again. Commercial pressure, eroded safety culture, the absence of proper process safety management. Each disaster extends the same indictment forward in time. The plant at Flixborough was rebuilt in a different form. It ran for a short time. Then the price of nylon collapsed, and it closed. Demolition followed in 1981. An industrial estate and a power station occupy the ground now. At All Saints' Church in Flixborough, there is a memorial, a pond, a bench, a plaque. In the same year as the disaster, Parliament passed the Health and Safety at Work Act. A decade later, the Control of Major Accident Hazards regulations followed, shaped in part by what had happened here and at Seveso. HAZOP, the Hazard and Operability Study, developed and systematized by ICY and later championed through ICHEM-E and its Loss Prevention Bulletin, became standard across the British process industry and spread through plants across the world. The discipline of process safety, still working, still developing, still carrying the lesson forward, owes a measurable debt to what was lost at Flixborough. 28 lives. One chalk line on a workshop floor. The river still runs through Lincolnshire. It does not look any different.